All right, welcome to 9.6 part 2, everybody. So remember, our goal here is to cancel out the bottom of our fractions, our denominator, so that I can just solve the top easily. Now, if you have something like part D, you'll see on the right side of the fraction here, we don't know what's really going into that until we factor it. So if you have a trinomial on bottom, or if you have something that can be factored, factor it first, and then you'll be able to truly see what kind of parentheses are being used for the bottom. So look at x squared minus 12x plus 20. Again, I want two things that multiply to 20 but add to be negative 12. So I end up with 10 and negative 10 and negative 2. And then remember, I want to multiply by what each thing is lacking, and this one's just a little bit more complicated than the other ones we did. So notice if I thought of my two kind of denominators as being x minus 10 and x minus 2, this fraction right here already has both, so it's good to go. This fraction here is lacking the x minus 10, and then this fraction here is lacking the x minus 2. Again, on top, I distribute into that. So for the first fraction, I've got 2x minus 4 over x minus 2, x minus 10. For the second fraction, and again, remember, I personally like to write this as a plus sign and then think of the negative 3 as being together. If you keep it a negative and don't change the signs yet, they will also work, but I prefer to do it this way. So I'm saying that's a plus, and then I'm going to use the negative in here. So negative 3 times x is negative 3x, and then negative 3 times negative 10 is positive 30. So it's kind of like I distributed the negative already. And then on bottom, x minus 2, x minus 10. The right side did not change. Now that required a little bit more work, but now we're at the same stage I was at in my other problems. So I can right away cancel that out, and I'm left with what's on top. So 2x minus 4 plus negative 3x plus 30 equals 6. And I'll go through and solve it. 2x plus negative 3x is negative x. Negative 4 times 30, or plus 30 is 26. Finish out the problem here, and I end up with negative x equals negative 20. Divide by negative 1. X is 20. Again, every single time when you do these, you got to check it because you don't know if the answer is going to work or not. I'm going to plug 20 in everywhere I see an x up there in the original problem. And this is one where if this was a test question, you'd be required to show your setup, but then after that, once you write this all down, I would expect that you would try typing that into your calculator, try typing the right side into your calculator so that you can check and see what happens. And when I did that earlier, I got 1 over 30 equals 1 over 30. So check, it works, and we have a regular solution this time. All right, scroll down when you're ready. Pause if you're not. Looking at part E, I'll help you out with this one because sometimes people forget that this is called a binomial because there's only 2 pieces instead of 3, but it still can be factored because x squared minus 1 can factor into x plus 1, x minus 1. And now if I pretend like that is that bottom then, and the 3 has a bottom of 1, if you think about it, this fraction over here is just lacking a x minus 1. And this part right here, the 3, is lacking both of them. So here's where this gets a little bit annoying because I'm going to have to multiply by both x plus 1 and x minus 1. Alright, so over here, because I've got the x minus 1 times 2 things, I'm actually going to have to FOIL it out. Alright, so in my mind I'm thinking x times 4x is 4x squared. X times 1 is 1x, and then I got inner is negative 4x, outer is negative 1. So sometimes I write a step in between before I write my final answer just to kind of save some time. So what I really got then is 4x squared minus 3x minus 1, and then again the denominator is x minus 1, x plus 1. Let's look at the right side of the equation. So now the first fraction doesn't change, so that's just 12 over here, this is where it gets a little complicated. I am going to want to either FOIL this out and get to the 3, but you know what, actually when I FOIL this, think about this, I just factored from x squared minus 1, so I know that the FOILed version of this would be x squared minus 1. So it's 3 times x squared minus 1. That makes our life a lot easier because, yeah, that is very easy to just distribute now. So that top is going to be 3x squared minus 3. And again, remember, x squared minus 1 factored to be this. So if I go the other way and FOIL it out, you'll get x squared minus 1. Check it if you don't believe me. All right. Here I go. I'm just going to write this down so I got everything formally here. I have all my bottoms the same, so I can pretend like I'm multiplied through by x plus 1, x minus 1, so they cancel essentially. And now this one ends up being harder because I have an x squared in my problem. Remember what we've been doing in other chapters. Whenever you have a x squared, it's called a quadratic equation. In a quadratic equation, there's many methods of solving, but luckily our textbook is super nice to us, and in all these chapters we've been able to use the factor method. What I mean is we're going to get everything to one side, so we're going to set it equal to 0, and then we're going to factor it. So I end up with 4x squared minus 3x squared is 1x squared. Negative 3x has nobody to combine with. And then I got 3 plus negative 12 plus negative 1. So that's negative 13 plus 3, which is negative 10. Once you get everything on one side and you have it set equal to 0, that is when you factor it. So I get x minus 5, x plus 2 when I factor it, because negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Remember, I set them equal to 0, so my two answers are going to end up being 5 and negative 2. And then I need to check them because it is very likely one of these is going to end up being extraneous. Not always, though. All right, I'm going to plug it in. And pause and use your calculator if you want to test it yourself. I end up with 21/6 equals 12/24 plus 3. I did that all on my calculator in case you're wondering. Just typed it all in. When you're typing these in, make sure that you use parentheses around stuff that has plus or minus signs. You know what? The first one ends up working. Check. So we're good on 5. And when I plugged in negative 2, it also worked. If you want to just trust me on that one, we could save some time. All right. So both of them work. Actually, both are solutions this time. Cool. All right. I want you to pause the video and try F. And when you have unpaused, I will have the answer showing. So go ahead and pause the video and try F and then unpause. All right, you can see the answer here. So it ends up being no solution. You solved it and got negative 1, but when you went back in and checked it, it doesn't actually work. So hint, make sure you don't forget to go in and check your solution. At this time, go ahead and look at G and H. Notice that H, I put the method 1 problem from the previous page. I want you to also pause and try these, and then if there's one of these that you didn't understand, please make a note of it so we can do it in class tomorrow and you can ask me about it. So again, pause the video and try G and H at this time. All right, check your answers for G and H. And remember for H, if you went through this and you're getting something that wasn't really working out, you may have ended up with x cubes or x squareds and had to do a much longer process than you needed to. Hopefully you still got the same answer. But remember that once you get to the stage where you've cross-multiplied, you always want to factor it if you can, because if there's a parentheses in common on either side, I could divide by that parentheses and they'll cancel each other. And when I did that, it made it into just a normal x problem instead of an x squared problem, so it's faster. Now if you kept them and you got an x squared problem, again, you should still get the same answer. So check your work. Again, write down any questions so you can ask me tomorrow. Thanks for listening.